In the last video, we looked at how we could use Euler's equation, which is e to the I theta equals the cosine of theta plus the I sine of theta. We looked at how we could use this equation to find the double angle identities for the trigonometric functions. Well, in this video, we're going to see how, again, the same fascinating connection between trigonometry and complex numbers and exponentiation, we're going to see how we can use that connection to find, this time, the answer to the cosine of, and I'm going to use Greek letters here, if we have alpha plus beta, and we could use any variables we wanted to here. It's just saying of any two numbers. It could be the cosine of 4 degrees plus 9.2 degrees. What this is going to equal in terms of other cosines and sines of those angles. And then also the sine. The sine of alpha plus beta. What will this equal? And we're going to again do it with the help of Euler's identity. Because in the last video, where we substituted in e to the I 2 theta, this time we're not going to do that. We're going to substitute in e to the I, and maybe you can guess it, alpha plus beta as our theta. Well, okay, right off the bat, we're going to do the same step. This e to the I alpha plus beta is indeed going to equal the cosine of alpha plus beta plus the I sine of alpha plus beta. And if you remember how we did this in the last video, what we're going to do is we're going to use, again, another exponent property to turn this exponent into some combination of e to the I alphas and e to the I betas, and we're going to connect it back to the real part of this and to the imaginary part, and we're going to show how each side mates, and we're going to find ourselves our sum identities. So let's do this. The exponent property we're going to use this time is that we're going to split up the exponent by additions. So let's do that right here. First, we can distribute. We have e to the I alpha plus I beta. And of course, if we have an exponent with addition, we can break this up. We can say this equals e to the I alpha times e to the I beta. And of course, what do we know this equals? Well, we know it equals the cosine of alpha plus the I sine of alpha times the cosine of beta plus the I sine of beta. And you can see we're going to get some product here. So let's scroll down a little bit. Let's calculate this product. First, we can FOIL it. So we have cosine of alpha times the cosine of beta. So let's just do it down here so we have some room. We have the cosine of alpha times the cosine of beta plus we have the cosine of alpha times the I sine of beta plus I cosine alpha sine beta plus I sine alpha cosine beta, I sine alpha cosine beta, plus I sine alpha I sine beta. But of course, when we have I squared, which is I times I, we'll make that into a negative. So we have minus the sine of alpha times the sine of beta. And here we have really quite a monstrous expression, but we can simplify it down. We can group together the terms with the imaginary I multiplied into them, and the real terms. So let's do that. I can even write them in the corresponding colors that I underlined here. So in real, we have the cosine of alpha times the cosine of beta minus the sine of alpha times the sine of beta. And here if I myself here, plus, now we have the I, we can take out, and we have the cosine of alpha times the sine of beta plus the sine of alpha times the cosine of beta. And still looking monstrous, but now we have ourselves here an answer. We have the red term here, the cosine of alpha times the cosine of beta minus the sine of alpha times the sine of beta. That is the cosine of alpha plus beta. And here in the imaginary, the cosine of alpha times the sine of beta plus the sine of alpha times the cosine of beta, that is this sine of alpha plus beta. So if we can go ahead and make use of this copy tool that I've been using a lot recently. We can go ahead and copy this here. That is the answer to this. And then we can go ahead and copy here. This is that answer right there. And I'll go ahead and rewrite it because it's getting a bit messy there with all the extra parentheses. But it's just the cosine of alpha times the sine of beta plus the sine of alpha times the cosine of beta. And you can see how most certainly these might get lost in discussion of trigonometry. Why in the world is it the case? The cosine, cosine, sine, sine, cosine, sine, sine, cosine. How is a student ever meant to remember this? Well, there are certainly good proofs of this, but quite a simple one, I think, and a short one, and a good one to remember if you're ever stuck on a trigonometry test or wanting to remember it, is to just rederive it. Just remember e to the I theta, replace theta with alpha plus beta. That even rhymes, so you can remember it more easily. And you have this really nice, simple, albeit long, explanation for why the sum identities work.